Hi everybody, my name is Blake Thof. I work for Murata Electronics, and today we're at Sensors Converge, and we have lots of new products on display. So I'm going to take you around the booth and show you what we got today. So the first thing we have on display here today is our soil sensor, and this is kind of a unique soil sensor. This isn't the soil sensor that you'd get from Home Depot. This is a soil sensor that can detect moisture, electrical conductivity, and temperature all in one sensor. And this would be used as a sensor additionally to kind of some type of connection devices or software to send this information from the soil back to the farmer. So they're monitoring the soil, they're changing their irrigation system or some of their processes based on the output from this. We have 9 electrodes in this device, which is way different from the 2 electrode ones you normally see because we can average out some values and outliers and also kind of adjust for rocks or mineral deposits in the ground so that our electrical conductivity measurements are very good and nice. Next up, we have our suite of new MEMS devices. So these are all of our accelerometer and gyros and inclinometers on this counter here. And we really pride ourselves on our stability over temperature and time. These are not consumer-grade accelerometers and gyros at all. We don't market them towards any consumer-grade applications. These are always meant to be for medical, industrial, or automotive applications. And that's because they're very robust devices, very high accuracy, and they can survive high vibration or high shock environments. As we move on here, we have our inclinometer. This is one of the highest resolution inclinometers on the market for a MEMS device. This resolution is about 0.0007 degrees, so very high resolution, about 36,000ly significant bits per G. And we have it on display here. As this demo rotates, this table will level using our sensor to measure the inclination. And if we look at the top here, we can see some very small numbers on the LCD screen, which we can actually just change by moving things on the table or leaning on the table, or we can see these very small changes in the inclination, even though we have it on this kind of big rotating table. As we move on, we have our waterproof pressure sensor demo over here. And basically our waterproof pressure sensor is meant for consumer-grade devices. It's very commonly used in smartwatches or fitness bands or kind of other elevation change monitoring devices. And today we have a drone on display here. This drone actually has a pressure sensor on board, and our controller has a pressure sensor on board. Here you can see it's extremely small. And you can actually see it maybe a little better in this case here. It's a very small pressure sensor. And its value proposition is that it is waterproof. It's for barometric pressure. And basically our demonstration here, as you lower or raise the controller, the drone will also lower and raise because they are both calibrated to the same pressure, analogous to the drone's elevation. Where did my thing go? I'll pass the microphone off here. Sorry, you have to explain because I don't know.
Okay. This is our radar. We use a 60 gigahertz millimeter wave for radar. So this radar can detect and track in human field. Also, we have a radar for automotive. This radar can detect a child presence to prevent accidents that leaving the baby in the car.
Then as we move on to the next one here, we have our friend from onsemi here showing off our Bluetooth module collaboration.
Hey, how's it going? So I'm Taylor from onsemi. We've been working with Murata. They've taken our Bluetooth radio, shrunken it down into a small system in package where it includes all of the RF matching, the power inductors, and the clocks and crystals. So in this particular demo, we're using a new feature of Bluetooth 5.2, which is angle of arrival. So we have a multi-antenna array underneath the table that is able to detect the small differences in phase as the signal arrives at it. This gives it a one-directional vector, and you can use multiple locators to then triangulate a 3D position, or in this case, find your position on a 2D plane. And using our chip, we have the lowest power Bluetooth radio in the industry, where our sleep current is down to 36 nanoamps. So these are fully ready to be integrated into a tag.